Welcome to my talk, Factory Honeypot. That's a story about our high interaction honeypot that we've built and we ran over the last 6 months. So again, welcome for coming. So we pitched this project originally in 2017 with the idea based off of news articles that I kept seeing about factories and things being attacked by ransomware and other attacks, and they kept saying that hackers are targeting the auto industry and stealing and demanding money. And so we wanted to know exactly how is this actually happening, specifically to factories or anything like that. So we sat down as a project team and we came up with an idea that we wanted to make a high interaction honeypot that looked realistic, like a factory that would do and make products if we wanted it to. By high interaction honeypot, we're talking about the ability for not only just to receive data, but you can actually go into it. There was a full network and a bunch of other things that made it look very, very realistic. As you can see in this video behind me, this is walking through some of the things that you could do. So we originally started with the equipment. The equipment that we had was a S7, and then we had a Omron, and then we had actually ended up with 2 MicroLogics. Building all this equipment and all that stuff, I had to get out my label maker and make it look nice so we could keep track of what each thing was doing. Our final design that we came up with was what you see on the screen here. We had an industrial cellular router that was on the internet, and you could see that the router itself was a Sierra Wireless. We had an IP address. We had to implement a transparent firewall to keep some of the attackers out that were overly persistent but didn't do what we wanted them to do. There was a D-Link switch and then a bunch of other information, Then that went to the PLCs that we had. We ran a bunch of stuff in virtual machines, and we actually had another laptop that ran as a file server. So we sat down originally, and we were like, all right, let's build logic. We're going to build the logic to make all of this happen. So how did we get there? We sat down and we realized really quickly, without actual equipment, that writing the logic was really, really hard to actually pull off. So we ended up having to design our HMI, and Charles Perrine on our team designed this HMI screen that then we could build the logic for. So as you can see, we were trying to become in our mind, we were going to be a company that's making something with a plastics injection molding process. So as you can see, we have a tank that had product in it with an agitator, that then there was a valve that went to a process heater, a pump to the injector, to a conveyor belt with a optical eye, and then a robotic arm that was for a palletizer. So we learned that we had to have that HMI screen first because we didn't actually have the equipment. So we ended up having to fake a lot of data that we faked within logic itself. So here we have a fluctuating RPM of our conveyor belt, so that when you start it in the video you saw before, and we'll show you again here in a second, it slowly builds up over time, and when you turn it off, it shuts, it slowly ramps itself back down. Because initially, with a lot of honeypots and other things that we've seen that have had logic, it's just on, off, and not a lot of making it super realistic. To do that, we had to do some random number generation. Now, some PLCs will support random number generation. Other PLCs, we had to build it within logic using math functions ourselves. So, depending on the PLC, we did one thing or another. Here's the video of turning it on. As you can see, the conveyor belt slowly starts. If you actually stop just the conveyor belt, it'll slowly take itself back down. If you stop the pump, the PSI will slowly come down as well, so on and so forth. So you kind of get in the picture. We're trying to make this look really, really realistic. That way, if an attacker got into this system, they would think that they were on a real factory. Okay. So, as I mentioned before, there was a couple different parts to this, one of which was the palletizer, and there was a robotics arm. So we had a system that was a robotics workstation. This was initially our first machine that we wanted somebody to compromise to test for lateral movement to an HMI or to one of our other systems. So a lot of the things we're going to talk about when we get to the actual incidents, you'll see that it is based off of the robotics workstation at first. We wanted to take the persona of a company that was accidentally exposed, and so we didn't expose everything to the internet, and we specifically chose some PLC ports and 2 VNC ports. At one point in time, we did have RDP open, but it actually, because of so much scanning, our cellular connection was not very good to attackers at sometimes, and so we kind of stopped that and went just with the classic VNC. So to really build this story up, we really, really wanted to make sure that we had a company that was able, you could find. Well, it's one of the things when you saw the HMI screen, we had the company on there. So we built a company, and the company that we built, we'll go through some of that details. It had 2 locations, one of which was in Chattanooga where I live. It actually made it a little easier for us to do some steps of making sure that the honeypot didn't bleed over into anything else or any other IP spaces that we might have needed. Here's the location in Chattanooga. This is the location in Los Angeles. They're real buildings. They're actually business incubators. It's believable that we could have been there. So there's, again, from the outside of the building, they're legitimate buildings that look like there should be industrial equipment. So if somebody went and took down to that level and wanted to look at it, here we are, this is who we are. We had IP addresses that we had domains for that pointed both to the factory, which was the cellular connection. The VPN was actually an IP address at one of those facilities that we could get access to. One of the things that we took in a little extra step for was also making personas and people. The people themselves, what we ended up talking about and doing and implementing was we had 4 major people that we wanted to work for the company. We needed an engineer, somebody who's a business planner, because we wanted if you really looked at this company, you would find that this person you wouldn't believe that this person didn't actually exist. So in total, we had 4 people that worked for the company. All of these faces are not actual people. We used thispersondoesn'texist.com and generated people. We even went to the level of having those phone numbers that were originally, they were actual phone numbers that you can call. And you would get a receptionist if you called those numbers that said, "Welcome to METech." The prototype around you, we made up a slogan and everything, and to dial certain extensions for different people. If you called that extension, you would get a voicemail from that person. So once we started implementing everything, we decided then we would go, how are we going to truly monitor it? So instead, we went for the full tap approach, and we used Shark taps here, and split it between the laptop where the VMs were running and the other laptop that we had that ended up being the file server and the PLCs themselves. This is all post-NAT, so on the factory side of it, we were tapping. So we were filtering out all the things that came to our router that we dropped. We took all those PCAPs and we put them into Malloc, which is a tool that was created by AOL. It's on GitHub. Highly recommended it. We also used Suricata and a bunch of other tool sets to help us in our monitoring and looking at the traffic itself. With that said, now we'll get into what actually happened. So we're going to spend the majority of this time, the rest of the time, talking about what actually happened. So here is our entire timeline of events that we have, starting with when the system went live on May 6th, down to the last incidents that we had before we shut it down right before the Christmas holiday. As you can see, it took a little bit of time before we actually saw events. So between May 6th and July 24th, we had little to no activity. It wasn't until early July, late June, we actually opened up the robotics workstation on VNC for remote clicking. We wanted to do that because we wanted to look like something happened and we made a mistake. There was, applying an update or something like that. So if somebody had been watching it and they couldn't do it, then they could. So it wasn't very long after that we did that, we started seeing things. So first off was May 24th, we had malware install. Then we had a phone fraud. We were then reinfected with that first malware. Then somebody came in and tried to enable RDP. Then same person from July 24th on August 2nd fixed their malware. Then we had people who would just get angry and log off the machines. And then we had ransomware and things like that. So we're going to walk through a couple of these. And we're going to start here. Okay, so this is host.exe. It was a Python installer that had a backdoor in it. So what ended up happening in this case was an actor came in, downloaded host.exe to their own machine, from one of their own web servers that they likely controlled. They downloaded that. We unpacked it, found out it was an Ares C2 that you can find on GitHub. And we were pretty excited about this. We're like, already, we have a backdoor installed. This is amazing. What's next? Over the next day or so, we started watching all the traffic, and it was a Monero miner. So on our honeypot that's running in a VM, we were doing crypto mining. It caused us some performance issues on our VMs. Our host laptop started overheating and shutting down. So we had to take care of that. That's part of the reason why he kept coming back and trying to fix his malware. And then finally, we just blocked him with that transparent firewall that we had. Next, we're going to talk about one of the ransomware. So this is a ransomware attack that we observed. We utilized VirtualBox monitoring and wrote scripts that based off of movements, it started doing recordings. Then we took those recordings and pushed them all together and made one longer video. In totality, this is like an hour-and-a-half long video that I compressed to 45 seconds. And what you saw originally was they came on, they actually ran TeamViewer. They downloaded TeamViewer, ran it, installed 3 files, executed them, and launched the ransomware. This is an hour-and-a-half of them also watching and making sure their processes are working. Part of those 3 tools, one of which was ransomware, the other 2 tools were to mount any drives, and the other one was to do really quick file system looks to see if make sure that they were encrypting all the files they wanted. We ended up having communications with this actor in which one of the goals we wanted to do, as I originally said, was I wanted to see what happened when they held a factory ransom. So we have a factory held ransom. So how smart were these actors? How much did they know about the actual processes and things like that? So we had communications with this actor. Originally, in this case, the original ransom was $10,000. We talked them down to $6,000. We never paid it. But one of the things that they really were looking at and trying to do was get paid, So they really would offer us to do one file for free to show us that their process worked. So based off of that process alone, we took, and they had this email, and they said, no important files, like SQL databases, things of important, those kinds of things. And I went, okay, I'm a factory. One of the most important files I have is my logic files, my backup of my logic files. So I sent them the Omron project file to see if they would decrypt it. They decrypted it, sent it back, and asked for money. So that showed me right there that we're not dealing with somebody who knew exactly what they really had. So then we rebuilt the system. Now, this ransomware attack itself had us down for 4 days. We were down for 4 days because, one, we were in communications, we shut down all the systems, and we were trying to act like a real victim here. So there is implications that things happen, and it can be detrimental. So. Next, we saw, it was sort of like ransomware, but it wasn't ransomware, it was just we were held ransom. Somebody came in, one insulted Mike, which we took personal because, again, we kind of took on some of these personas ourselves when we emailed. So, you know, Mike's an idiot, and wow, we were a little offended. Like, you guys, you don't even know Mike. And it's his fault. So this person came in and installed a backdoor. Then they exfiltrated roughly 7 gigs of data, and then came in later after they were done and happy with that, they deleted files. And those are the files they wanted us to email and contact. Now, in the file server itself, we actually made up a bunch of fake files. The way we did that, and it's documented in our paper, was more or less just making files with nothing but zeros in them. So my guess is when we actually contacted this person, that he finally had realized he had null files of, you know, like megabyte of zeros. And so we actually never got a response from this person. But I really wanted to call him out for calling Mike an idiot. So then this attack is what I'll call the good guy hacker. We like to leave, so Mike turned out to be a little passive aggressive. He would leave stickies, such as system is fixed, don't click on anything, and don't minimize any windows, Mike. He's super passive aggressive. Wouldn't call out, wouldn't just go talk to Jans, who was actually doing all this stuff. So we got this one where the actor said, "Hi, I found out that your PC have an open port of 5901 that will allow hackers like me to break into your PC. So I want to tell you to set a password for your VNC. Metra." It's a pretty good hacker handle there. We had people come in and drop their malware, and then they would change and set a VNC password, which was pretty interesting. One time they couldn't even get back into it themselves because they forgot what the password is or whatever, so we helped them out and reset everything. And so it's pretty interesting that we have people in situations like this where people are going out and they actively go on a machine to tell people that they're insecure, but almost in a threatening manner. So I found that pretty interesting. So then what happened next? This one still perplexes me, so I would love to hear any thoughts on what happened here. And if you want to see the full video in totality, I have it. I'll be more than happy to show it to you in regular speed, so if you want to waste an hour and 40 minutes tonight, come talk to me. But what happened was we had an IP address come in, open up a web browser, and look for the Symbian OS emulator. For the next hour and 40 minutes, they proceed to download it, download all the dependencies such as Java, Perl libraries, things like that, install them, then get into the system or launch the Symbian OS emulator. They set the date to the correct date, the time that was on the computer. And then what happened after that is they went to Google. They T9'd google.com and went there. Then they clicked on images, then they clicked back on web, and then they closed this. And then they deleted everything that they had just done. That's it. An hour and 40 minutes to see if this machine that they had on the internet could run an emulator that could also get to the internet. We looked at the files themselves that they downloaded because we, of course, saw them do it, so we knew where they came from. We could not find any malicious code, anything like that in any of these. So we still are no idea what really happened here, other than somebody really wanted to see if a phone from 2003 could get to the internet from this machine. We kind of reset the VMs. I'm going to go back to one that was on that first one last. So then we reset the VM after the ransomware each time we did. One of the things I would like to point out about the ransomware things is we had lots of good activity, but acting like a true victim and not isolating the one attack we have, we wanted to act like a true network in a factory. So what happened was we would have a good attack. We had a good backdoor. We had, at one point in time, very good beacons coming out on a steady, regular pace from our machine from some malware. And then the ransomware attack happened and killed everything. So then we reset, hoping they come back in, but they don't. One of the ransomware attacks that we actually called it ourselves renameware. So renameware is, we called that because it literally just runs the Windows rename command. And I like to call this one out because this is one of the only attackers who they really went into the ABB industrial folder and made sure they did it. They took this out of their script and made sure that they went in there via command line to make sure that they got this file. Now this is actually pretty destructive itself because there's no table kept while they run this script to remember what it was before the rename. So there is absolutely no way you could come back. So knowing this, because they asked us to pay Bitcoins to a wallet, but never a contact address. So what we ended up doing was just resetting it. The guy didn't like that. So he came in, he deleted a bunch of files, the whole ABB industrial folder, the next day, and wrote a script that popped up about 100 tabs to an adult site. And we thought that was pretty rude and interesting, but a little bit both at the same time. But this is very destructive, actually. So while the ransom that he was asking for was cheap, there was no way you were ever going to get back any of your files. So there's a couple of people in the room that know about this, one of which, Mike Tucker, who's over there in stage 2, reached out to me. Does everyone in here know who Vis is? Yeah, okay. Vis found my honeypot. And I had to write a message to him while I was on the phone with Mike, who was talking to him, and finally we all touched base with each other. He had reported this to ICS CERT, which is a good thing, because we did have an exposed ICS system in the US, and he reported it to ICS CERT, but I had to prove it to him. So the way I did that is I got on this machine, said, "Hi, Vis," and then we closed everything out. We called each other. After about a 4-hour discussion with Dan, I had convinced him finally it's a honeypot. It was a really, really, really good honeypot. In fact, he sent an email to me and a bunch of other people that he had contacted about this with the subject, "The most elaborate honeypot." We took that as validation. That a security researcher himself, who does lots of talks about things exposed online, just had no idea this was a honeypot. In fact, after our conversation, he then tweeted later that he needed some rum like now. So again, more validation that we did what we set out to do, which was create a realistic honeypot with great data, great logic that looks real, and everything. So one of the things is, right before we shut everything down, we opened up the HMI. What those videos I showed you earlier of the HMI in operation, that actually was attacks. They would come in via VNC and just click stuff. The most destructive one was somebody came in, and usually what happened was they turned on the factory, immediately saw things going, and they hit off as fast as they could. One person, however, let it go on. They just left. It was about 4 hours before I finally just shut it down. Now, an interesting thing was we declared over the holidays we were in maintenance mode. And so all of our tanks would have been empty and everything like that. So there would have been some destruction here that an unchecked process went on for 4 hours with nothing to be made, nothing to in anything. So you can imagine the consequences to the equipment here. That was the incidences. But let's talk about some of the stats we saw, some of the numbers. This is the main countries for all of the traffic we saw. The darker the blue, the more the traffic. If you want more information on that, on all this, it's in our paper that was released earlier today. The last slide will have the link. So this is all the traffic. This is for the HMI and robotics workstation. This is S7. No, sorry. This is all the PLCs. This is S7. This is Ethernet IP. And this is Omron fins. You can see different landscapes based off of, and of course this is based off of geolocation of IPs, and there is flaws in that, but this shows a little bit of a story. PLCs of different makes and models are being looked at from different regions. Such as in the Omron, Japan is really, really dark because it's a Japanese PLC. So that's not, people are looking for things that they know. Now, how much of this, and I know everyone's asking, how much of this traffic to the PLCs was legitimate traffic? Such as properly formed. Well, I can say by looking at a lot of the data that we had, the information was things that I wrote when I worked for Digital Bond. They were in-map scripts, the same ones, or the SCADA Strangelove PLC scan. In total, we saw 8,905 IPs. 592 of those IPs we could classify as scanners. Total number of scanners of unique IPs per day. We had 10 IPs per day that were scanners. 85 IPs per day that were not. Total number of traffic. We did a lot of data over a cellular card. Roughly 126.7 gigs over 6 months. It's not a lot, but it is at the same time. So in conclusions, don't put your control system on the internet ever. Attackers seem more interested in using a clean IP than causing issues to productions. Maybe we were a little too realistic to attract lurkers who just wanted to play, APT Chattanooga. If you want to run a high interaction honeypot, daily interactions are needed. Deal with incidents as they happen. Do not wait until other ones collapse your honeypot, and attackers will be mean to Mike. This was when I locked out the tags. I locked out the PLCs. This will look familiar to everyone. And this is a link to the paper. So, with that, Hopefully you guys enjoyed the research. I'll be around all night, all the way through. I leave Friday morning. So come and get me at any time, and we'll see you guys soon.